Nice connecting with you, my wonderful scholars. Jam past question 2002, question number 8. The hydrostatic blood pressure difference between the head and feet of a body standing straight is 1.65 exponential 4 Newton per meter square. Find the height of the body. Okay, our question today is centered on pressure. But recall, it's blood pressure. Therefore, that's pressure in liquids. In physics, we have two kinds of pressure. Pressure on solids and pressure on fluids. And each has its own formula. So the blood pressure is not solid. It's fluid pressure. Blood is liquid. When we talk about fluid, we're talking about liquids and gases. Okay, let's start. Let's start with confidence that we can do it. The hydrostatic blood pressure difference between the head and the feet of a body standing straight X. The pressure was given 1.65 times 10 raised to the power 4. Do not mind the two more statements. It's just blood pressure of a person. Okay? Find the height of the boy. So the boy that has this blood pressure, we're looking for his height. Question mark. It's not known. Then density of the blood is given as. We use this symbol for density. This D with small leg. Symbol for density. And that of the boy is 1. Density of his blood. 1.1 times 10 raised to the power 3 kilogram per meter cube. Then acceleration due to gravity of the mother earth. The boy is an earthling. Okay. Then we'll be having 10 meter per second square. These are the parameters provided. Then the question becomes, how do we get this boy's height? With information pertaining to his blood pressure, density of his blood, and acceleration due to gravity of the mother earth. It's possible. That's one of the wonders of physics. To do that, there is a formula for solving pressure in fluids. And the formula says pressure is equal to density times acceleration due to gravity times height. Recall this density. Then you don't need to cram this. This platform does not support cramming. Let's prove it. Recall, we want to prove this. How the formula came about. Recall, the pressure you know is force over area. This is pressure on solids. However, you don't discuss fluids with area. You can bet me that you don't say, I need some area of water. No. Water is not two-dimensional. Water is three-dimensional. Therefore, you request for volume of water, 3 dimension. So we'll find a way to convert this area to 3 dimension. And the only way to do that, recall that area is already 2 dimension. Length times length is area. But we're talking about length times length times length. That is volume. Okay. Recall. Emphasis. A is L times L. Then V is L times L times L. This 3 dimension. And that's what our fluids represent. This is not solid. We want to shift away from solid formula to pressure on fluid. Then we'll play smart, observing the rules of mathematics. Notice what I will do. Then I'll be adding heights to this area to make it 3 dimension. Height is also length. Then the height will now complete the 3rd dimension, making it 3. Then I'll be having A times H. Mathematically, to make this equation to be equal to P, I'll also do F times H. Otherwise, I'll fail the rule of mass. So this height here must also be there to balance the equation. So that when H cancels out, it returns back to F over A. This is the condition that this is equal to that. Observe. These two formulas are the same. I added height here to convert this from 2 dimension to 3 dimension. I must also put that same H at the numerator part, so that I will have something equivalent to that. Okay, take your time and believe that. And I know that you know it. When you cancel H, because they are the same, you return back to F over A. So mathematically, it's correct. Then let's finish the formula a bit. So I'll be having F times H over, instead of using A times H, now I'll now go to volume. Volume is area times height. Okay, hope that's clear. Okay, let's forge ahead. Then recall F is equal to mg. Force is the same as weight. Weight is force. So weight or force is mass times acceleration due to gravity. That's how G entered the equation. Let's carry on. Then I will now solve F for this. I'll be having P is equal to, instead of F, I'll be putting mg. Mg, then our hash all over V. Mg hash over V. Then observe something. Notice something. Notice something. M over V represents something. M over V represents something. To make that clear, recall density. In physics, you must know your equations, your formulas. Recall that density is equal to mass over volume. Mass over volume is what we call density. Mass all over volume is density. Then finally, we'll be having pressure on fluids is equal to M over V represents density. Next thing is what? G and H. So that's how our formula came about. We call that formula pressure on liquids and gases. Or one name, pressure on fluids. Okay, let's solve now. I believe everything is now clear to you. So we know the boy's blood pressure, we know the boy's blood density, we know G is a constant. We're now looking for the boy's height. Therefore, let's make height the subject. Height becomes pressure over density and G. Pressure of the blood divided by density of the blood times G. Then we solve. So what's the blood pressure? We have 1.65 times 10 raised to the power 4 over what density of the blood? 1.1 times 10 raised to the power 3 times G of the earth was given 10. So when you solve this equation, 1.65 exponential 4 divided by 1.1 exponential 3 times 10, the height of the boy becomes 1.5 meters. 1.5 meters by. You can see we've gotten a boy's height by knowing his blood pressure, density of that blood, and the acceleration due to gravity of the earth. Wonders of physics. Please stay tuned as we push ahead. Thank you.